Hello geometers and seekers of truth. In this video we will apply what we learned previously about the areas of similar polygons, and we want to find the area of this big triangle here, CDE. But first you notice that we have some parallel lines up top here, so we can say that angle D and angle B are congruent, and that's by alternate interior angles. And then angle A and angle C are also congruent. That's also by alternate interior angles. So we can say that triangle ABE, that's the smaller one up here, is similar to triangle CDE. Okay, CDE and ABE are similar. And let's see the similarity or the scale factor that we have here. So to find the scale, we can see that the height here of the smaller triangle is 3. And the height of the larger triangle here is 7. Okay, so the scale here is going to be 3/7. So to find the area of the big triangle, we could use the area of the smaller triangle. And so let's find the area of the smaller triangle here. So the area of triangle ABE is equal to 1/2. The base is 12. Times the height, that's 3, so we're going to get 18 units here. Okay, and to find the area of triangle CDE, well, we can compare the two areas. We can look at the area of ABE, excuse me, over the area of CDE. That's the bigger triangle, and we know that it must be equal to the scale squared. So it's going to be 3 squared over 7 squared. So what we already know, ABE is 18. CDE, I guess we'll call that X. That's the thing we're looking for. And that's going to be equal to 9 over 49, or 3 squared over 7 squared. So working out all of the details, we get 18 times 49. That is going to be equal to 9 times X. And then divide both sides by 9, and we get 18 times 49 over 9. And that's going to give us an area of 98 units squared. Okay, that's going to be the area of the larger triangle. Now, there's another way we can certainly do this. We can try to figure out the length of CD here and then use the area formula with that, and both would be equally good. Okay. I'm going to continue on here and then show you how we can use similar figures in a different way besides just figuring out the missing lengths and then finding the area. So the area of a regular nonagon, that's 9 sides, is 303 square feet, and it has a side length of 7. A similar nonagon has an area of 99 square feet. What is the side length of the smaller nonagon? So here we can actually try to find out the different side lengths of the smaller nonagon without using the similarity statements, but we don't have to. Okay, so let's compare the areas here. So the areas of the smaller one is 99 over 303. Okay, so the small one on top, bigger one on the bottom. The bigger one has a side length of 7, and we want to know what's the side length of the other of the smaller shape. Okay, so notice here what I have here is a scale, but these are lengths that I'm comparing over here. So when we do that, we have to square these lengths in order for us to use them in a proportion with the areas. And doing so, now we can work out all of the details. So it's not too messy to do this. It's going to be 99 over 303 times 77 squared, or 49, and that's going to equal X squared. Okay, so working that out, I did this on my calculator, and I ended up with 1,617 over 101 is equal to X squared. and then take the square root of both sides, and we get that x is approximately 4.00. Okay, feet here would be our unit. Okay, so there's using what we know about the ratios of area, we can actually solve this problem in a much more efficient way than just to simply using different formulas for areas of nonagon or some other tricky method. As always, keep working hard. Thank you for watching and have a wonderful day.